Okay, this is the third in our series of videos on solving triangles, and in this video we're going to focus on the angle-angle-side condition, and we'll also do the angle-side-angle condition in this same video. And so in these two conditions you're given two angles and a side. So let's start here and let's just type in an angle. Let's say let's do 110 degrees. And let's say the next angle, of course it's got to be less than 70 degrees because it's got to be less than 180 degrees for the two together. So let's do something smaller, 33 degrees. And then let's get a side length, let's just say 5. And so notice, as usual, this will construct this to scale, and we'll also show the other sides and the other angle and the area as well. Now, what about computing this? Well, notice in this case we're given, well, first thing we can do is find the other angle. And we know that the three angles add up to 180 degrees. So 180 degrees minus 110 degrees minus 33 degrees is 37 degrees. So now we know all three angles. Okay? But notice that we're given an angle and a side opposite, A and A. And so we can use the law of sines in this case. So here's the law of sines. So the sine of angle A over side A is equal to sine of angle B over the length of side B. And it's also equal to the sine of angle C over side C. And notice this first fraction we know completely in our current situation. We know both angle A and side A. And so if we know either one of these, either angle B or side B, we can find the other one. And similarly for C. And so we were right here. And so let's show all of the computations. So, of course, the first thing we're going to do is use the angle sum theorem to find the other angle. So it's 180 degrees minus A minus B. So it's 180 degrees minus 110 degrees minus 33 degrees. That's 37 degrees. We do know that all three angles must add up to 180 degrees, or pi radians. Now, we can use the formula A over sine A equals B over sine B. Multiply both sides by sine of B, and we get this expression here, and hopefully things are in there like we want. We have side A here, we have angle B here, and angle A in the bottom. Notice that A and A are one's in the top, one's in the bottom here. And we can work that out on our calculators. Okay, so we can do, let's get in the habit of putting in parentheses around the numerator. 5 times the sine of 33. Let's notice that we are in degree mode. Close parentheses around the numerator. Divide by the sine of 110. And that will be side B. Let me store it as B. Might want it again in a minute. So it's 2.897963775 as far as the calculator goes, or about 2.90, whatever our length units are for A. So if A is in centimeters, then B will be in centimeters as well. In a similar manner, we can see C over sine of C is A over sine A, so multiply both sides by sine of C, and I can do second inner and go back, and the only thing I have to do is change that 33 degrees to 37 degrees, which was the angle for C. And this, let me store that as C. I don't know if I'll need it again or not. Let's see here. And there we get 3.202190854. Of course, that's rounded off already to lots of decimal places, and if we round it off to 2 decimal places, that's 3.20 centimeters. Area is always 1/2, or 0.5, times A, which is 5, times B, which I've got stored and then times the sine of angle C. Angle C was 37 degrees. And there is the area, 4.3600954342, or about 4.36 square units. Okay, if we do an angle, so this one is angle side, okay, and if we do angle side angle, so notice this is angle side 2 on this and if I go to angle side angle 2, this one also inputs two angles, 60 degrees and 87 degrees, and the side between is 4 centimeters, and this draws it to scale here. Now notice this time the angles that are given are two angles, and it's the side that's given in between, whereas over in the angle side situation, what we were actually originally given was the angle here at B, the side at A, and then the angle opposite A up here was given. But notice, eventually the first thing you're going to do is find the other angle. So whether you're in angle side or angle side angle, either one, the very first thing you're going to do is compute that other angle by subtracting from 180 degrees. And then, either way you do it, we show our computations here. So there's the subtraction to find the other angle. So notice that now that we have all the angles, we're going to have an angle and a side opposite. This one originally didn't have an angle and a side opposite, so we have to compute C first. But once we do that, we've got an angle and a side opposite. That's exactly the situation that we can use law of sines to solve. So we know A over sine of A is C over sine of C. Multiply both sides by sine of A. C times sine of A over sine of C is this, and let's see if I got everything in the right place. So this is C, this is angle A, this is angle C, and so we can do this in the calculator. So it's 4 times the sine of 60 degrees. Let's put parentheses around it. 4 times the sine of 60 degrees, and then divide by the sine of 33 degrees, which we just computed. Oops, an extra digit there. Alright, and this should give us the A, 6.360362355. Okay, I'm going to store that as alpha A, because if I need to do any further calculations with A, like to find the area in a minute, I'm going to want to be sure to keep all those digits. And similarly, we can find the missing side B. B over sine B is C over sine C, so multiply both sides by sine of B, and we have this. So I should be able to go back to this same thing that we have here, and really just change the 60 to the appropriate measure of that angle B, which is 87. Leave the rest of it alone, and let's actually store that as B for side B. And that's 7.33424878, or about 7.33 centimeters. We find the area as, oops, there needs to be a 1/2 here. Okay, I think that the final answer is correct, I hope. We'll check it out here in a minute. So 1/2 AB sine of C. Now, even though this says 6.36, that's not what I'm going to be using. I want to be using all of the digits that I have here. So I'm not going to, which is why I stored them as A and B. So now I want to get the area. It's 0.5 times alpha A times alpha B times the sine of angle C. C was 33 degrees. And this should be the area. Yeah, that's correct. 12.7032914 square units, square centimeters in this case. Alright, let's have you try one here. Let's suppose we do a 30 degrees, 47 degrees, 8 centimeter triangle. Why don't you work that one out? 30 degrees, 47 degrees, 8 centimeters. Work that one out. Come back and check in a minute. Press pause now. Okay, so we said 30 degrees, 47 degrees, 8 centimeters. That's the angle side. So I need to go to the AAS2 tab here. Change A to the first angle, which was 30 degrees. Change B to 47 degrees. And change the side to 8 centimeters. And this draws it in actual size. So if I actually were to print this out, this would actually print out exactly the right size. So it could be done by measuring, but of course you won't get a very accurate answer there, precision there. So let's figure it out. So first thing we do is find angle C. It's 180 degrees minus A minus B. That's 103 degrees for angle C. And in fact, if you were going to construct this, you'd probably do that first, draw A of 8 centimeters, do 103 here, 47 degrees here at B, and just find where they meet up here. And then just double check that that angle at the top is 30 degrees. And then you could measure the other sides. They should be about 11.7 and 15.6 centimeters respectively. So we want to find better measurements for those, more accurate. It's B, well, here it is, A sine B over sine A, and that should be 11.7. A sine C over sine A should be 15.59, and the area is 1/2 times A times B times sine of C, and that is about 45.61 square centimeters. So you can check that one out. Let's try one more. 20 degrees, 9 centimeters, 110 degrees. Figure that one out, come back. Press pause now. Well, this time it's the angle side angle situation where we're starting with 20 degrees here. The side in between is 9 centimeters and the other angle on the other side is 110 degrees. And so it's going to look just like this. Okay? And here are the steps. Once again, solve for the other angle first by subtracting the two angle measurements you have from 180 degrees. So we get 50 degrees for the other one. Now we use that C and side C, which we know in our computations here, to get that fraction C over sine C known. Multiply, we have A over sine A equals C over sine C. Multiply both sides by sine A. Plug in your C, your angle A, angle C. Work it out. It should be 4.02 centimeters, and similarly side B is 11.04 once you have A and B. Multiply A and B, not reduced versions, but all the digits you have in your calculator, and then times 1/2 and times the sine of angle C, and you should get hopefully 16.99 square centimeters. So there we go. If we're given any two angles, find the third one. Then you have an angle and a side opposite, so we can use law of sines to get us started. In fact, we use exclusively law of sines and the angle sum theorem. So start with the angle sum theorem, get the other angle, then use law of sines to find the two sides in this basic formula that we've always used for the area.